Write crisp, focused prompts that get correct, concise answers in Python. By the end, you will build a small prompt pipeline, get deterministic answers, compare phrasings, and control answer length with a simple parameter. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced in simple Python. Prompt engineering matters because it directly improves relevance. Relevance here means how well an answer matches the facts you provide. It also affects latency and token cost, so you trade off brevity against completeness. In practice, clearer prompts can cut token usage and latency by a large fraction while reducing hallucinations in many tasks. Conceptually, prompt engineering is about 3 moves. First, structure the facts. Second, ask a focused question. Third, constrain the answer. It shines when you can supply a known corpus of facts and expect precise extraction. Its limit is open questions and tasks that need broad world knowledge beyond your facts. We will build a 5-step pipeline that assembles prompts from facts, queries a deterministic responder, scores alternate phrasings, applies a max words limiter, and then returns the top facts with answers. Now we will assemble a compact, well-structured prompt from facts and a question. This snippet builds a compact, well-structured prompt from a list of facts and a single question. It shows how to concatenate core facts into a short context block and then place the question at the end. The goal is clarity. Facts first, then the instruction. The snippet demonstrates how to prefer concise fact sentences and to avoid repeating irrelevant details. If you make the context longer, the answer may become more accurate, but uses more tokens and increases latency. If you shorten the facts, the responder may miss required evidence and guess. Next, we will feed that prompt into a deterministic responder to get a stable answer. This snippet sends the constructed prompt to a deterministic responder and returns a single fixed answer. Deterministic here means the responder will prioritize consistency over creativity, producing repeatable outputs for the same prompt. The snippet shows how to pass the prompt and receive a plain textual answer, then perform a basic validity check. If you switch to a non-deterministic mode, you will see more variation and creativity, which can help brainstorming but hurts repeatable evaluations. Using deterministic mode improves reproducibility and makes ranking phrasings reliable. Now we will compare different prompt phrasings by a simple ranking rule. This snippet generates several alternate prompt phrasings and ranks them by a pragmatic rule. Prefer the shortest valid answer. It runs each phrasing through the deterministic responder and then filters results for correctness against expected constraints. Shorter valid answers often indicate tighter instructions and less redundant wording. If you allow longer outputs in the ranking phase, you may prefer richer phrasing that trades brevity for clarity. Adjusting how many phrasings you try increases compute and latency, but can find better prompt templates to reuse across similar queries. Next, we will constrain answers using a maximum words parameter. This snippet enforces an answer length budget via a max words parameter, which is a simple cap on words in the reply. It shows how to add an instruction into the prompt asking the responder to stop after the specified number of words, and how to verify that cap on the return text. Tuning this parameter controls the trade-off between conciseness and completeness. A smaller max words reduces token cost and speeds responses, but risks truncating necessary detail. A larger max words gives fuller answers, but increases cost and may invite redundant phrasing. Finally, we will retrieve top facts and the final answers using relevance scoring. This snippet selects the most relevant evidence and returns the top facts paired with their answers. It uses a simple relevance scoring mechanism to rank facts against the question, and then builds a compact context from the best matches before calling the responder. The snippet demonstrates how retrieving the top few facts improves precision, and how raising the number of facts can improve recall at the cost of tokens. If you change the number of retrieved facts, you directly influence accuracy and token usage. So pick a sweet spot for your corpus size. Putting it all together, the pipeline shows a clear pattern. Assemble concise facts. Use a deterministic responder for repeatability. Test alternate phrasings and prefer concise, valid answers. Apply a controlled max words budget. And retrieve only the most relevant facts. Each piece reduces one common failure mode: ambiguity, non-determinism, verbosity, or irrelevant context. Recap what it is: a 5-step prompt engineering pipeline for precise, repeatable answers. When to use it: when you have a fact corpus and need consistent, evidence-backed responses. One caveat: overly tight constraints can drop needed detail and harm accuracy. Next step: tune the max words parameter while measuring accuracy and latency on a held-out set to find the best balance for your corpus. If practical AI engineering helps you build reliable systems, subscribe and watch the AI engineering videos.